A quick note before we begin. I am currently fixing the homework so that you'll be able to work on it again. So I missed a box to check in the settings that cut the homework off after the due date to only view and review. So I want you to be able to go back and do the homework assignments again. So I have to change some settings on the homework assignments. I just want to make sure that I don't wipe out all your old answers. Although if I do and you have to do all the homework assignments over again, you're welcome. You get to do the problems over again. That's just more practice. I know y'all don't see it that way, but eventually you will. So let's remind ourselves of the solving triangles game. The solving triangles game is that I give you 3 of the 6 pieces of a triangle and you find the other 3. So this is given 3, find 3. In the solving right triangles version of the game, one of them is a right angle. So one of the 3 that you're given is a right angle. So once we have one of the angles is a right angle in the triangle that we're looking for, because we're solving a right triangle, that simplifies our toolbox and adds some things to it. We have that the sum of the angles in a triangle is 180 degrees. So alpha plus beta plus a 90-degree angle is 180 degrees, which we can simplify to that alpha and beta are complementary. Also, once we're dealing with a right triangle, we can use the Pythagorean theorem, which says the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. In this formulation, we have to make sure that C is the hypotenuse, that is the side opposite the right angle. In addition to these 2 things, we have one thing that's all angles, one thing that's all sides. We need something that connects angles and sides, and those are the trig functions that we learned about. So sine of theta is opposite over hypotenuse. The fact that we're using hypotenuse in defining our trig functions reminds us that this only works with right triangles. We can use sine of theta and cosine of theta in other triangles in the future, but we'll have to talk about them other than without using hypotenuse. Because once you use the word hypotenuse, you have to be talking about a right triangle. So sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. So when I write sine of theta is opposite over hypotenuse, notice that there are 3 things that we could be looking at: theta, opposite, and hypotenuse. So to use any of these 3 trig functions, I need to know 2 of those things. If I know 2 of the sides, then I can use an inverse trig function to find the angle. So I can take sine of theta and solve it for the opposite. So I could say opposite is hypotenuse multiplied by sine of theta. I can solve this for the hypotenuse by saying that the hypotenuse is the opposite divided by the sine of theta. We can also use sine of theta is opposite over hypotenuse to solve for an angle. Transcription should be on now. Thank you for the reminder. We can also use this to solve for an angle if we remember to use inverse trig functions. So I could say theta is sine inverse of opposite over hypotenuse. And we want to remind ourselves when we write sine inverse, we say sine inverse, not sine to the -1. It's not a -1 exponent. It's a notation for the inverse sine. So sine inverse or inverse sine of opposite over hypotenuse. I wrote it in single line syntax because that's how we're going to type it into our calculator. The buttons are going to be second, and then we'll press the sine button, because in blue, at least on the TI-84, that's how we access the sine inverse button. The other name for inverse sine is arc sine. So sometimes we try to avoid this -1 exponent looking thing by writing arc sine. So we'll pronounce that arc sine. That way we were not in danger of confusing sine to the -1 and sine inverse. So one thing that we want to be careful of, and we've talked about it a little bit, is making sure that we round to the specified decimal place. So I want to talk today about rounding to a specified decimal place, because our calculator will demonstrate, our calculator will display way more digits than we will want. So we need to talk a little bit about rounding styles. So I do want to specify a few things about how we want to round. In these first two quizzes, I either specified round to the nearest degree or round to the nearest tenth. So I'm just specifying the place that I want the rounding to go to. So I want to talk about the concept of rounding and the two techniques that we can use for specifying where we want rounding. So the idea behind rounding, if you're past halfway, then keep going. That's the way I think about rounding. A lot of times we talk about rounding with a set of rules, a lot of if-then statements. Look at the place that you want to round to. If the next digit is 5 or more, then go up. If the next digit is 4 or less, then keep it where it is. That's a set of rules describing specifically what you should do. So if we want to round to the nearest tenth, that's one place after the decimal point. Let's say I've got 14.58. I was looking at the blank space. And I said, come up with a number that's more than 5. And then I drew a blank. Okay. So the nearest tenth is where the 5 is. We look at the next place, the hundredths place, and if that's more than 5, then we round up to 14.6. So this 5, this is the tenths place. And the 8 is more than halfway. It's 14.55 would be halfway. So if you're halfway there, keep going. 8 is more than 5. Eight is more than 5, so we keep going, and we round this to 14.6, the next highest tenth. When we're rounding to the nearest tenth, if we're at 14.58, we're between 14.5 and 14.6. Those are the 2 tenths that we're in between. When I say round to the nearest tenth, you have to decide which one is closer. So on a number line, here's 14.5. And here's 14.6. Right in the middle, at 14 is 14.55. This is halfway there. That 14.55 is exactly halfway to the 14.6. So if we're looking at 14.58, 14.58 is closer. 14.58 is closer to 14.6 than it is to 14.5. That's why 14.6 is the nearest tenth. We're making a decision between 14.5 and 14.6. If we wanted to round the number 14.51 to the nearest tenth, then we go back. We have not gone halfway. So if I have 14.51, the tenth place is the 5. And 1 is less than 5. So if I'm at 14.1, oops, so 14.51. Oh, 14.51 is closer to 14.5 than it is to 14.6. So 14.5 is the nearest tenth. We go back to the previous tenth. Any questions? I want to make sure that we cover this because it's some of the quizzes are requiring that you round to a specified place. So I say round to the nearest tenth. We got to make sure our rounding is on point because I'm asking you about rounding That makes it part of the problem. And if your calculator is telling you 14.58, the nearest tenth is 14.6. 14.5 is farther from 1458 than it is from 14.6. Then 14.58 is from 14.6. So I'm writing down I'm entering 14.6 as the correct answer, and 14.5 gets marked wrong. I don't feel too bad about this because you have unlimited number of attempts on the quizzes. And if all you have to do is go re-round everything, I'm not too worried about that. Any questions? All right. So there are some things that we have to keep in mind. When we're rounding to the nearest tenth, you have to fill in the 10th spot. So if you're rounding to the nearest tenth, there's got to be something in the 10th spot, even if it's a 0. So when rounding to the nearest tenth, there has to be a digit in the 10th place. So for example, if I have a number 23, round to the nearest 10. If I have a number, say 23.04, there's a 0 in the 10th spot. Here's the 10th place. Four is less than 5. So we are not halfway. We are not halfway yet because it's 0.04. 0.05 will be halfway to the next 10th, but we are not halfway. So we round to 23.0. We go back to the previous 10. Notice that we need to write 23.0 because we're rounding to the nearest 10th. 23 is not rounded to the nearest 10th. We can't just drop the 0 because we were told to round to the nearest 10th. The nearest 10th is 23.0, not just 23. If all we were writing is 23, that could be as little as 22.5 and as much as 23.49. But when we say 23.0, that next digit after the 3 is definitely a 0. And we need to know that. Any questions? Once again, the 23.04, sometimes it helps if you visualize the 2/10 you're in between. So on a number line, the 2/10 will be between 23.0 and 23.1. Halfway will be at 23.05. 23.04 is closer to the 23.0. One more thing about this rounding business before we get into the other style of rounding. When you're rounding to the nearest 10th, you only look at the hundredths. After the 10th is a 4, we don't look at anything else in the number. So for example, if I said round to the nearest 10th, and the number is 23.049, 0 is in the tens place and 4 is less than 5. We don't care about the 9. 0 is the tens place. And 4 is less than 5. We are not halfway. So rounded to the nearest 10th, this is still 23.0. And we go back to the previous 10th. We think about 23.049. 23.049 is still before 23.05. 23.049 is still before 23.05, which is halfway. It's very close. But it is not halfway. So back to 23.0 it goes. Any questions? All right, so we want to make sure that we got our rounding skills all ready to go so that we're not guessing at things. And we want to make sure that we read the instructions, because sometimes I'll switch up and instead of the nearest 10th, I'll ask for something to the nearest 100th. So we just got to make sure that we get the right decimal place. Whatever decimal place is called for, something has to be there. So even though we want to say 23.0 is the same as 23, in an environment where we are rounding, 23.0 is different than 23. Once again, we could think of 23. We just write 23, it's somewhere between, say, 22.5 and 23.49. But if we write 23.0, this does not go all the way down to 22.5. It's going to be a lot closer in between. Any question? The other place that we have to make this decision is if we get a number that's with a bunch of 9s, right? So if I get, we want to round to the nearest 10th. sometimes we have difficulty doing this because we feel like we're changing too much of the number. So if I'm like, oh, 19.99, and we want to round this to the nearest tenth. The tenth here is this middle 9. So this is the tenths place. The next digit is a 9, and 9 is more than 5. So we are past halfway. So that means we go up to the next tenth. The next tenth is 20.0. A lot of times we feel uncomfortable doing this because we feel like we're changing too much. But the tenths that we're in between, we think in terms of a number line, the tenths that we're in between are 19.9 and 20.0. That's the next tenth. Halfway is 19.95. And 19.99 is closer to 20.0. So even though we're reluctant to do it, when we have 19.99, we got to switch 2000, 00. Party over. Oops, out of time. We're uncomfortable doing that. We want to just drop the 9 and keep all these 1s and 9s, but we got to replace them all. It just goes up to 20. Any questions? Comment? Snide remarks? So one of the ways that I'll ask you to round your answers is I will just specify the decimal place that I want. Round to the nearest tenth, round to the nearest hundredth, round to the nearest unit, that's the ones place. There is another way that we could round things. So another rounding style is to deal with significant digits or sometimes significant figures. I think I say significant digits more often. I can't remember what the book says. I should probably read that thing sometime. Significant digits is another way of not necessarily rounding, but it's a way that I could request a certain precision in your answers. Rather than specifying the nearest tenth, the nearest hundredth, I could specify significant digits. So the reason that we would use significant digits is that sometimes we're using measurements that just aren't precise enough to be, where it would make sense to round to a certain value. So for example, let's suppose that well, for example, there are some, let's suppose that I say that my weight is 240.5874 pounds. That just doesn't make any sense at all. There's no way that my weight can be that precise, because I'll just exhale and that will change what it is. I could sneeze and change it even more. That's too much. It's going too far. With significant digits, maybe if your scale is really good, you can get 3. So I could say 240. That's what I would probably say right now. But it doesn't make sense to go too far. You're using too many digits. You're trying to represent precision that just isn't there. Now, your calculator doesn't care about this stuff. Your calculator is just going to give you all the digits. Calculator says all is significant. So when I look at, say, for example, the sine inverse of 5 divided by 9, it's going to tell me that this angle is 33.7489886 degrees. That is way more precise considering all we have is a 5 and a 9. We got one digit in these 5s and 9s. It doesn't make sense to use this many digits to represent the angle. Especially if we went out and measured the 5 and we measured the 9. If we went out and measured something that was 5 centimeters long and the other thing that was 9 centimeters long, it probably only makes sense to say it's about a 30-degree angle. So the other way we could ask for a place to round is using significant digits. And you do this by, you count the number of, we have to learn how to count significant digits. So when we're counting significant digits, we count from left to right, beginning with the first non-zero digit. So count left to right. Starting with the first non-zero digit. Go left to right, starting with the first non-zero digit. So for example, if I have a value of 0.07, the first non-zero digit is the 7. And it's the last one, so there is one significant figure. I'm already doing it. Significant digits or significant figures. When I first started training on significant digits, they were called significant figures, so we abbreviated them as sig figs, and now we're stuck with it. Y'all can break the cycle by just saying digits all the time. But if you write it as sig dig, they're not digits, they're digits. So you're rewriting sig dig, and it's just weird. So if I have 0.075, I have two significant figures. The first non-zero digit is a 7, and then we start counting 5. We count all the digits from left to right. So if I have 0.0750, here's the first non-zero digit, and then we count 1, 2, 3 significant figures. We just count until the number stops. So if I have a number like 375, that's also 3 significant figures. When I put 375.00, I have 5 significant figures. You just start with the first, go from left to right, starting with the first non-zero digit, and you keep going until the number ends. There are some strange cases where it becomes a little bit unclear. So for example, if I have the number 1000, let's talk about some ambivalent cases. Not ambivalent, some unclear cases. So if I just write 1000, this is at least one significant digit, but it could be up to 4. So the precision of this number, just writing 1000, is not clear. It's 1 to 4 significant figures. We don't know if we should count these zeros as significant or not. If this number has been rounded to the nearest 1000, then it's one significant figure. But if this number has been rounded to the nearest 100, we might be justified in saying that there are two significant figures. If this has been rounded to the nearest 10, then we would say there are 3 significant figures. And if it's been rounded to the nearest unit, or the nearest 1, we could say that there are 4 significant figures. But just looking at the number, we can't tell. We have to know where the number came from. So a little bit iffy. What we would do in this scenario, if we want to make sure that just looking at the number will tell us how many significant figures there are, is that we can write the number in scientific notation. So if I say that this is 1 times 10 to the 3rd, that's one significant figure. If I want to write this with 1000 with 2 significant figures, then I could write 1.0 times 10 to the 3rd to get 2 significant figures. 1.00 times 10 to the 3rd with 3 significant figures. And if I round it to the nearest unit, and I want to demonstrate to my audience that I have rounded this to the nearest unit, I will round it to the nearest unit with 4 significant figures. Any questions? So in general, if you haven't been instructed to round to a particular place, then you should use a number of significant figures based on whatever number you're given that has the least number of significant figures. So if you're not told to round to a particular place, and you're just told to use significant figures, then whatever number in your calculation that has the least number of significant figures, you would use that number for your final answer. So unless otherwise specified, We could complicate this with some other rules, but the least number of significant digits in your given information will be the number that you should use, unless otherwise specified. So in some of the problems that you've had so far, you've been given 2 significant figures for an angle, for example, and I said round to the nearest 10th anyway. So your answers had 3 significant figures. That's because I was specifying round to the nearest 10th, because that problem was not just about the trigonometry calculation. It was also about your ability to punch it into the calculator correctly while avoiding rounding error. So that's why I have some extra significant figures. But if I don't specify, then I should be taking the least number of significant figures and using that for the answer. Any questions? How's everybody, okay? It's hard to tell. Everybody looks shocked. I can tell what you look like, because this is what you look like when you're in class. Whenever Michael, is everybody okay? Everybody looks at me like this. No matter what's going on, that's what y'all look like. If we were in a physical classroom right now, I appreciate the thumbs up. That's really cool. But for the most part, you're looking at me like this. And it means so many things. I'll be like, oh, any questions? Does this make sense? And you look at me like this. And it means a lot of things. It could be like, this is so easy. I don't know why he's going over it. I'm going to express the fact that this is super easy and therefore boring by giving him my move faster face. But then right next to you is someone who's like, oh, this is going too fast. I need to communicate that Leach needs to slow down and explain things more. So I'm going to give him my slow down face. Here it comes. And then there's some of you that are out there like, oh, like sleeping. You learn to sleep with your eyes open. It's a college skill. The more advanced version of the college skill, this is for in the classroom, is when you can sleep with your eyes open and make your hand kind of move a little bit like you're taking notes. So you're like, well, but you're actually asleep, right? That's the advanced level where it looks like you're taking notes. And then every once in a while, you like nod in agreement. So you're like sleeping. You know what I mean? So practice that skill. It's not really as important in online school because you could just do this and turn off the camera. And then actually just go to the, and then you could just mute yourself and then go to the kitchen and get yourself a refill of coffee or whatever. You know what I mean? I'm pretty convinced that some people, even though you're not required to be at the online meeting, some people feel obligated to log into the online meeting, but I'm pretty sure they just leave. They like log in so their computer is watching, and then they just go AFK. Because I like sign off, and then like there's like a bunch of people still hanging around. I'm like, oh, are there any questions? But it's all just names, so I can't tell if anybody's actually there. You know what I mean? And then there's going to be a voice from the other room. It's like, oh, no, I'm totally there. Actually, I'm just kidding, because if you're going to walk away, you're probably going to mute me as well. I don't know. Any questions on significant figures? It's just something there that you need to get used to, and it just takes practice. There's also the practice with scientific notation. So scientific notation, if you haven't seen it, it's always a number between 1 and 10, and this is where we move the decimal point. So this is 1 times 10 to the third, and 10 to the third is 1,000. 10 to the fourth is 10,000s and so forth. So like if you go out and buy a car for $25,000, you could say it's 2.5 times 10 to the fourth. All right, you're right. There are probably people going out and playing Red Dead Redemption because I put the Red Dead Redemption music on. So I was like, oh, I haven't played that for a couple of days. Any questions, comments, or snide remarks? All right, cool. Let's look at an example problem. And let's practice the significant figures. We're going to look at a problem, and they're going to look similar, but they're not quite going to be the same. So let's do the whole thing. Solve the triangle. So I'm going to draw a right triangle because that's the game that we've been playing. I've given you one of the pieces of information. This is a right triangle. So one of the angles is a 90-degree angle. And in this problem, I'm going to say that the hypotenuse, I'm going to use our standard labeling, is 15 feet. And this base angle here, let's call that beta, is 56 degrees. So if this is angle beta, that means this is side B. If this is side B, then this third side is side A, and this angle up here is going to be alpha. We need to solve the triangle, which means we need to find alpha, angle alpha, side A, and side B. Since we have two angles, the best practices dictate that we should subtract to find the third angle. So the first thing that we're going to go for is angle alpha. We have two angles, so we should subtract to find the third. That's just best practice. Alpha is 90 minus 56, or 40 negative 4, so 34 degrees. Right, 56 and 34 is 80-10, yeah. So alpha is 34 degrees. As soon as we have two angles, we subtract to find the third one. That's just best practice. Now we need to use one of these angles and the hypotenuse to find A and B. So now we're going to need to bring our trig functions in. We can either find A or B first. So good news, we have a choice. Oh, but unfortunate news, we have to make a choice now. I'm going to find A just because I'm going to go alphabetical. Beta was the given angle, so B might be a better choice to go for. But since it doesn't actually matter, I'm just going to go alphabetical and find A. Now I could read A as being opposite the 34 or adjacent to the 56. So let's find A next. Side A next. Just because we have to pick one. And we have two things that we can do. We can read A as being adjacent to 56 or opposite the 34. So A is adjacent to 56 degrees, but we can also say A is opposite 34 degrees. So now we have yet another choice. We have to decide if we want to use the 56-degree angle or the 34-degree angle. Neither one of these has been rounded, so each one is just as good as the other. The best practices say use as much given information as possible, but the 34 hasn't been rounded, So we're not introducing any error by using 34, but let's follow best practice and use the 56. The 56 was given. So I'm going to use this one. A is adjacent to 56. And the other information I have is that C is the hypotenuse. So I've got adjacent and hypotenuse. That means we'll use cosine. So cosine of 56 degrees is adjacent A over hypotenuse 15. Take the two pieces of information that were given and drop them into our trig function or our trig ratio. To solve for the numerator, I just multiply both sides by 15. And so A is 15 cosine of 56. And that's what I'll ask my calculator about. So 15 cosine of 50. First, I'm going to make sure I'm in degree load. 15 cosine of 56. 15 cosine of 56. Only took like 3 tries. 8.387893552. That's excessive. The 15, the given 15 and 56 indicate that I should use 2 significant figures. We'll use 2 significant figures. So it'll be 8 point something. So I'm going to have 8 and then the 3. So I'm going to round at the second significant figure. So that's going to be 8.3. 8 is more than 5. So we're past halfway to 8.4. So I'll say A is 8.4 feet. Note that A is opposite the 34. So we could have gone with sine. So in an alternate reality, I said, let's be risky and go with the sine. So I might have said the 34 is just as rounded as the 56. There's no rounding error here. So maybe we'll be rebellious and say that the sine of 34 degrees is A over 15. But now we're reading A as opposite because we're using sine. So we solve the same way. A is 15 times the sine of 34 degrees, and we'll get the same thing. 15 sine of 34 is the same thing, 8.387893552. Rounding to 2 significant figures, we're still at 8.4 feet. At this point, we still need to find the third side B. We have 2 sides, so we could use the Pythagorean theorem, or we could read B as being opposite the 56 or adjacent to 34. So our options here are to read B is opposite 56 degrees. We could read that B is adjacent to 34 degrees, or we have 2 sides we could also use the Pythagorean theorem. So we have three options. This is even worse than last time. We have three options. Notice that not only do we have B is opposite 56, but we also have A, which is adjacent to 56. So we could use sine, cosine, or tangent. So because we have the opposite, we could use sine or cosine, or sorry, sine or tangent. We could go adjacent because we could just use cosine. Or we can use the Pythagorean theorem because we have two of the three sides. So now we have to make a decision. So we should appeal to our best practice. The best practice says use as much given information as possible. So Pythagorean theorem would require rounded information. Tangent would require rounded information. So the Pythagorean theorem and the tangent would use rounded information. Now we could avoid rounding error by using all these digits. And our calculator remembers all these digits, so maybe we're fine doing that. Or we could just use sine or cosine to avoid rounding error and follow best practice of use the given information whenever possible. So I could say that sine of 56 is equal to opposite over hypotenuse. And so B is 15 times the sine of 56. So 15 sine of 56, 12.43, lots of stuff. You should never feel compelled to write down all these digits. Since we're rounding to two significant figures, it wasn't specified to round to a particular decimal place, we'll go to two significant figures. And we'll say B is equal to 12 feet. $34 hasn't been rounded. It's got the same number of significant digits as all the rest of the stuff. So it would also be reasonable to use cosine because the 34 is right on the money. So I could say that the cosine of 34 degrees is adjacent over hypotenuse, so that B is 15 times the cosine of 34 degrees. So 15 cosine of 34 is 12.4, the same. And so we would still land on 12 feet. Any questions? Now, once again, we can avoid rounding error by just using more digits. We could set up a tangent for this problem. We could set up a tangent for this problem by saying that the tangent, let's see, 56 is opposite. So tangent of 56, or B is opposite of 56. Tangent of 56 is opposite over adjacent. so that b is equal to 8.4 times the tangent of 56. But I would not want to just type the 8.4 into my calculator. That number has been rounded off. So if I just typed in 8.4 times the tangent of 56, I get 12.45. In this case, rounding to two significant figures, we're not in any danger. But if we want to make sure that it lands on the 12.43556359, instead of typing 8.4, I would take the 15 sine of 34. That's where the 8.4 came from. If I multiply this number times the tangent of 56, now I get the 12.43556359. In this case, it didn't make a difference that we use rounded information. We still come up with 12. But we're trying to avoid rounding error by only rounding at the end and using given information whenever possible. The same thing would happen if we used the Pythagorean Theorem. So that would, we could have said 8.4 squared plus b squared is equal to 15 squared. So b would be the square root of 15 squared minus 8.4 squared. So if I do the square roots of 15 squared minus 8.4 squared, we see that we're a little bit off of where we want to be, 12.427. In this case, rounding to two significant figures doesn't make a difference. But if we want to avoid rounding error, I can just take where the 8.4 came from and run the calculation as 15 squared minus answer squared. And then we land exactly where we expected to, 12.43556359. Not that we were going to be writing all those digits anyway. Any questions? This only seems like a lot to remember because it's a lot to remember, and you have to remember all of it all the time in perfect detail. So once you get over that, and nice and straightforward. Any questions? Comments? Snide remarks? How's everybody? What do we think of trigonometry so far? Super fun, right? I really like trigonometry as a class, and it only gets better. Solving triangles is kind of a very appropriate thing, or not appropriate, a very applicable thing. There are lots of situations where we want to solve triangles. So some of the homework problems, there's this weird setup where there's this plane and someone's looking at the plane, and all you need to do is figure out where the right triangle is and figure out what your given information is. And then you make once you have a right triangle, you know how to solve the right triangle. So all these problems are set up for you to build a right triangle and solve it. But once we start marking two-dimensional space with angles, as well as just horizontal and vertical components, two-dimensional space becomes much more interesting. So trigonometry is a great class for looking at those ideas. Any questions, comments, deep thoughts? Is everybody going to go play Red Dead Redemption now? Specifically Red Dead Redemption 2. Yes, there are, just like there are arc sines and arc cosines and arc tangents, there is an arc secant, an arc cosecant, and an arc cotangent. So remember that secant is the reciprocal of sine. So just a quick note. Let me switch back to the board. So I'm going to take cosecant. Cosecant theta is 1 over sine theta. So cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So it's not the inverse of sine, it's the reciprocal of sine. Or it's not the sine inverse function, it's a multiplicative inverse. So if we had something like cosecant theta is equal to, say, 7 over 5, because we have hypotenuse. Dang it, I was intended to write this. So since cosecant is the reciprocal of sine, sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Now, what we'll notice on our calculator, what you may have noticed, because some of the homework asks you to do these problems, and then I conveniently don't tell you how to do them. That's just the little game that I play. I assign problems, I don't tell you how to do those problems. I just ask you to guess and see how that goes. So notice on your calculator, there's no cosecant buttons or secant buttons or cotangent buttons. So we have to modify things. Since there's no cosecant button on our calculator, I'm going to have to modify this a little bit. I'm going to have to notice that if cosecant of theta is 7 over 5, then sine of theta is 5 over 7. So if I want to solve for theta, I'll do the sine inverse of 5 over 7. So I'll do sine inverse of 5 over 7 to get at the cosecant, if cosecant of theta is 7/5. I think I'm going to need to hire someone to do the closed captioning, because the last line says something about the closed theta is 7 minutes. And that's not what I was saying. I'm not making fun of the automatic captioning. It's amazing that it can even figure out that I'm using language, much less figure out what I'm saying and type it on the screen. Especially when I have things like theta. See, it's convinced that I'm talking about cheese. But I mean, it's still just, it's an amazing piece of technology, but it's funny when it translates what I say. No shade, respect. It just translates math funny sometimes. All right, that's going to do it for today. Continue working on your homework as soon as I let you continue working on the homework. And there's going to be new assignments coming from chapter 2. That's going to do it for today. I will see y'all on Thursday. Everybody have a good couple of days, and thanks for playing.